Alright, I'm going to read from page 155. This is motor functions of the spinal cord. So emerging evidence indicates that the spinal cord contributes to the control of movement, but the precise role of these spinal reflexes in the control of movements is still debated. However, there is an increasing evidence that normal motor function is influenced by spinal reflexes. In fact, some authors claim that reflexes play a major role in the control of voluntary movements. These investigations believe that the events that underlie volitional movement are built on a variety of spinal reflexes. Support for this idea comes from the demonstration that spinal reflex neurons are directly affected by descending neural traffic from the brainstem and cortical centers. The spinal cord makes a major contribution to the control of movements by preparing spinal centers to perform the desired movement. The spinal mechanism by which a voluntary movement is translated into appropriate muscle action is termed spinal tuning. Spinal tuning appears to operate in the following way. Higher brain centers of the motor system are concerned with only the general parameters of movement. The specific details of the movement are refined at the spinal cord level via interaction of spinal cord neurons and higher brain centers. In other words, although the general pattern of the anticipated movement is controlled by higher motor centers, additional refinement of this movement may occur by a complex interaction of spinal cord neurons and higher centers. Thus, it appears that spinal centers play an important role in volitional movement. Another motor control function of the spinal cord is the withdrawal reflex, which occurs via a reflex arc. Reflex arc is the nerve pathway from the receptor to the CNS and from the CNS along a motor pathway back to the effector organ. Reflex contraction of a skeletal muscle can occur in response to sensory input and is not dependent on the activation of higher brain centers. One purpose of a reflex is to provide a rapid means of removing a limb from a source of pain. Consider the case of a person touching a sharp object. The obvious reaction of this painful stimulus, is to quickly remove the hand from the source of pain. The rapid removal is accomplished via reflex action. Again, the pathway for this neural reflex are as follows. Sensory nerve, pain receptor sends a nerve impulse to the spinal column. Interneurons within the spinal cord are excited and in turn stimulate motor neurons. The excited interneurons cause depolarization of specific motor neurons which control the flexor muscle necessary to withdraw the limb from the point of injury. The antagonistic muscle group, the extensors, is stimulated, is simultaneously inhibited via the IPSP. This simultaneous excitatory and inhibitory activity is known as reciprocal inhibition. Alright. Another interesting feature of the withdrawal reflex is that the opposite limb is extended to support the body during the removal of the injured limb. This event is called cross-extensor reflex and is illustrated by the left portion of figure 7.17. Notice that the extensors are contracting as the flexors are inhibited. In summary, evidence exists that the spinal cord plays an important role in voluntary movement, with groups of neurons controlling certain aspects of motor activity. The spinal mechanism by which a voluntary movement is translated into appropriate muscle action is termed spinal tuning. Reflexes provide the body with a rapid, unconscious means of reacting to painful stimuli. Alright, hold off there. That's 155 and part of 156. Motor functions of the spinal cord. See ya.